Okay, in this section we're going to be talking about titration. And titration is basically a way to quantitatively figure out the exact tipping point when something is at that equivalency spot. So when we talked about neutralizing acids and bases, it would be that exact point where everything has been neutralized. So it's not an acid and it's not a base, it is completely neutral. So the video we're watching here is just a gentleman kind of working through the process and the equipment that's used. And he's adding an indicator there, and an indicator will tell us a color change that's an indication of what's going on. And so we want to get this titration to where it is just perfect amount. One drop too much can make it too acidic, or one drop too little, it will still be basic and it's not completely neutralized. So these stoppers control how much liquid is added to the known solution, and then from that we can extrapolate how much of the unknown was needed or the concentration that was needed. And so as you can see, swirling it there, and the one on the right is way too concentrated. And so the one on the left, can you see it's just barely changed color, and that's the perfect amount that we would need. And so we go through a lot of trial and error in a lab to figure that out, and some pretty in-depth processes. And again, it can come down to just one drop, and you got to swirl and add another one. So today's today's activity, we're going to be looking at how do we do these calculations for titration.
Okay, so in this video we're going to talk about normality more than molarity, but these things, we need to know the difference between these two terms, okay? So we've learned about molarity, and molarity was the concentration of an entire solution. Okay, so for example, we might use sulfuric acid. So we've got H2SO4. So if I have a 0.8 molar concentration of sulfuric acid, that is for this entire solution, okay? All of these ions together. When we're talking normality, we are switching gears here, and this is the concentration of hydrogen ions if we're talking about an acid, or hydroxide ions if we're talking about a base, that are floating around in that solution. Okay. So if we take our H2SO4, and let's say we needed to find the normality, which we're going to need to do this to use our equation for titration. If we dissociate our H2SO4, like we've learned, this is going to have hydrogen ions, and we'll have sulfate ions floating around. Okay, and so if you remember, I have two here, so there should be two hydrogens here. And so when I'm talking about normality now, I'm only talking about these hydrogen ions. So when I go this direction, because there are twice as many hydrogen ions, I need to multiply this number by 2. So I might have 0.8 molar sulfuric acid, but if I'm talking about the normality and I'm looking at these hydrogen ions, this number is going to be 1.6 normal for that acid, okay? Okay, so now what do I do with this value once I've calculated or looked at the ratios of hydrogen ions here and I multiplied this by 2? Well, I would take this value and I would put it in this equation to solve for normality. Okay, so normality and molarity, they can be solved for each other, but they are not the same thing, okay? Okay, so let's say we use this equation to solve for the normality of an acid. How do I then find out its total concentration instead of just its hydrogen concentration, because that's what normality is? So for example, we'll stick with our sulfuric acid. So if you take, if let's say we solve for 0.8 normal was my answer using this equation to find its concentration, okay, what do I do? Well, it's still this difference here. So instead of multiplying my answer by 2, if you're going this way, you're going to divide by 2, okay? And so this concentration of sulfuric acid would be 0.4 molar sulfuric acid. Okay, so here is a sample problem that we will work through. So it says, what volume of 0.5 molar nitric acid will completely neutralize 20 milliliters of 0.56 molar calcium hydroxide? Okay, so I know I need to take these molarities and make sure that they are converted to normalities for this, okay? So nitric acid is 8, so it is HNO3 plus and minus. So we're going to dissociate this first, okay? So this is going to turn into our hydrogen ion and our nitrate ion, okay? So it's a 1, I don't need to put any numbers in front of those. And then we're going to check our calcium hydroxides, okay? So calcium hydroxide is CaOH2. So when this dissociates, we're going to have calcium ion and hydroxide ions. Now, how many do I need? It's going to be 2 of those things, okay? So we take a look at our answers here. 0.5 molar, so we're going to write molarity, 0.5 molars for this whole thing, but I need to convert this to normality. And so since this is 1 and this is 1, I don't do anything with this number, so it's going to be 0.5 normal. Okay. Now, if you take a look over here, it says that we have 0.56 molar calcium hydroxide. So this is 0.56 molar calcium hydroxide. But now, what about the normality? Well, I have twice the number of hydroxides here, so what do I need to do with this number? I need to multiply that by 2, okay? And so that's going to be 1.12 normal, and that is for my hydroxide ions, which means that's my base. This is for my hydrogen ions, so this is my acid. Okay, so now we use our equation Na times Va, normality of the acid times the volume of the acid, is equal to normality of the base times the volume of the base. So the normality of the acid is 0.5 normal acid times, well, that's the volume, that's what we're solving for, equals 1.12 normal for my base times the volume of my base, which was 20 milliliters. Okay, so these numbers multiplied together is going to be 22.4, and that's normality of the base per milliliter. To get Va by itself, I divide by 0.5 normal for my acid. What I do to one side, I do to the other. So 0.5 normal acid. Normalities canceled. My answer will be in milliliters. And when we do this, my answer will be 44.8 milliliters of my HNO3, my nitric acid. Okay? So when you work out these problems, you got to make sure you convert molarity to normality. If we need to, we can multiply times 2. These numbers go in our equation, which is up here. And then we solve for what is missing. Okay? And then that is the answer for this one. We're going to try one more problem. Okay, here's another sample question. Now we're solving for a concentration, okay? So I'm going to be using this normality to solve for the normal, and then we have to reverse and change it to molarity because that's what concentration is. So if 25 milliliters of 0.05 molar caloric acid is added to 20.8 milliliters of strontium hydroxide, what is the concentration of strontium hydroxide? So we're going to dissociate both of these compounds first, and we're going to kind of see what goes on. So I have hydrochloric acid, okay, and this is going to dissociate into hydrogen ions and chloride ions, okay. Does it give me molarity here? Yes, it does, okay. So 0.05 molar right there goes here, but now I'm going to convert this to normality. Well, 1 and 1, I don't do anything with this number, so this is going to be the same answer. Okay, those are the same numerical answers. Remember, this is the hydrogen ion, this is the entire compound. Okay, I have strontium hydroxide. Strontium hydroxide would be this as a compound. Strontium's a +2, hydroxide's a -1. Okay. So when we dissociate this, we're going to have strontium ion and hydroxide ions floating around. How many of those are we going to have? Well, we're going to have 2. Okay. So in this example, okay, what we're going to do is we're going to try to solve for the molarity number here, okay? And so what does that mean? When I get my normal answer right here, at the end, we're going to be working backwards. So if I'm going this way, molarity to normality, you would multiply by things. If I'm going this way, backwards, I'm going to be dividing if you need to. I'll just let you off the hook. The sample questions or the questions we have on the homework, you do not need to divide, but I want to show you this because these two things, normality and molarity, are not the same thing, okay? But let's continue. All right, so I'm going to take what I know and put it in where it goes. The normality of the acid is here. 0.05 normal for the acid times the volume of the acid. Do they give that to us? Yes, they do. Times 25 milliliters. And this is the volume of the acid. Okay. It's going to be equal to the normality of the base. That's what we don't know for now, but we know how much of the base we had. 20.8 milliliters, and this is the volume of the base. Okay, so there's our equation. These things are going to multiply. We're going to get 1.25 normal for the acid per milliliter. Okay, so to get the normality of the base by itself, I got to divide by 20.8 milliliters. What I do to one side, I do to the other. 20.8 milliliters. Okay, milliliters are going to cancel. And this is really just normality, but dividing, we get 0.05 0.06 normal for the base. So that is this number, okay? Now, what do I do to get the concentration? Because I'm working backwards, I need to half this number, okay? So I'm going to be dividing by 2 going this direction. So 0.06 divided by 2 because I'm going this way. My final answer is going to be 0.03 molarity concentration for my strontium hydroxide. Okay. Now, again, on your homework, okay, on your assignments, none of the things that you're solving for you do not need to divide because they're all 1 to 1. But I wanted to show you this because the normality and the molarity are not the same thing. When I work one way from molarity to normality, I would multiply. If I needed to work backwards from normality to molarity, you would divide. I hope that makes sense, guys. Get after it.